So, dear students, today we will discuss Poisson distribution. Okay. In last class, we discussed binomial distribution. Okay. So, which depend on two cases. The event is either success or failure. That's why it is called binomial distribution. So, in binomial distribution, okay, in binomial distribution, probability of x equal to r is equal to NCR p power r q power n minus r. Okay, here n is finite and r is finite. Okay, na? And p also finite value which lies between 0 and 1, and q is nothing but 1 minus p. Okay, in binomial distribution, the experiment is everything is clear. For example, if you toss a coin twice, okay, the outputs are, that is the sample space, HH, HT, TH, TT. Okay, here it is very clear that the number of heads, okay, the number of only one heads, two possibilities, the number of two heads, one possibilities, the number of no heads is one possibility. So it is everything is clear. Okay, na? And it is fixed also. Suppose the probability of getting two heads, the probability of getting two heads is equal to 1 by 4. It is clear. Okay, na? But in some cases, okay, in some cases, the trials we can't say properly. For example, the number of road accidents in a city in a specific time, we don't know. Maybe the road accident happen 1 or 2 or 3 or no happen. Okay, na? The number of snake bites in a city in a particular time, we don't know. Okay, na? So this type of things, otherwise the number of accidents in a factory. Okay, so this type of things we can't say the proper number, you can't say the proper number. Okay, na? అంటే ఇటువంటివి మన ఇప్పుడు బైనామియల్ డిస్ట్రిబ్యూషన్లో మనం ఎగ్జాక్ట్గా చెప్పొచ్చు అనమాట. బట్ పాయిజన్ అంటే ఇప్పుడు నేను చెప్పిన కేసు అనమాట, ద నెంబర్ ఆఫ్ యాక్సిడెంట్స్ ఇన్ ఏ ఫ్యాక్టరీ ఆర్ ఇన్ ఏ రోడ్ యాక్సిడెంట్స్ ఆర్ స్నేక్ బైట్స్ ఇన్ ఏ సిటీ ఇన్ ఏ స్పెసిఫిక్ టైం. సో ఇవన్నీ కూడా ఏంటంటే మనం ఖచ్చితంగా ఇంత అనేసి మనం చెప్పలేము అనమాట. ఎస్, సో అటువంటి వాటి కోసం ఏంటంటే మనం పాయిజన్ డిస్ట్రిబ్యూషన్ అనేది యూజ్ చేస్తాం అనమాట. ఎస్, ఓకే. ఇప్పుడు ఇక్కడ చూడండి, ద నెంబర్ ఆఫ్ ట్రయల్స్, ఓకే, ద నెంబర్ ఆఫ్ 1 trial, 2 trials, 3 trials, సంథింగ్. ఓకేనా, ఎవ్రీథింగ్ ఇస్ ఫైన్. బట్ ఇన్ పాయిజన్ డిస్ట్రిబ్యూషన్ the number of trials is infinite అనమాట. We don't know. ఓకేనా, either finite or infinite also. Okay, so in that case we are using the Poisson distribution. Okay, so in Poisson distribution, probability of x equal to r equal to e power minus lambda into lambda power r by r factorial, where r equal 0, 1, 2, so on. Yes, yeah, here lambda is called, okay, here lambda is called, lambda is, so Poisson variate or Poisson distribution parameter, Poisson distribution parameter. Okay, na? In binomial distribution the parameters are n and p. Here lambda is the parameter. Okay, fine. This lambda is very very small. Okay, na? This lambda is very very small. Okay, now in Poisson distribution sum, okay, sum of the probabilities of R, okay, sum of the probabilities of R is equal to 1, okay. R is running from 0 to infinity. R is running from 0 to infinity because R equal 0, 1 to up to infinity, okay. So as usual in binomial distribution, the sum of the probabilities is 1, okay, fine. Now one more point here, the mean, okay, or expectation equal to lambda, yes, and variance is also lambda, variance also lambda, and standard deviation is equal to lambda, which is equal to sigma, which is equal to root lambda. Clear? In Poisson distribution, sum of the probabilities is 1 and mean equal to lambda, which is Poisson variant, and variance of the Poisson distribution also equal to lambda, and standard deviation, which is lambda equal to which is sigma equal to root lambda. Clear? Okay, next so frequency of the Poisson variant, okay, frequency of the Poisson variant, which is repeated n times, is n into probability of x equal to r, okay. So that equal to n into e power minus lambda into lambda power r by r factorial. Clear? Okay. Next mode, okay. So what is mode? Okay, next mode. Okay, so mode of a distribution of a random variable, okay. So mode of distribution of variable r is maximum probability, okay, is for which probability of x equal to r is maximum, for which probability of x equal to r is maximum, okay. అంటే మనము r equal 0, 1, 2, 3 we are calculating the probability of x equal to for different r values. In that, the maximum value is called the mode of the probability, the Poisson distribution, okay na? So here in Poisson distribution, okay, in Poisson distribution the mode is depend on the Poisson parameter, okay. Here in PD, that is in Poisson distribution, mode is depend on lambda, in binomial distribution mode is depend on np plus p, but here mode is depend on lambda, okay. So if lambda equal to k, okay, where k is a integer, then mode is k, if lambda equal to mode is k and k minus 1, So I will write that. Okay, if lambda equal to k, which is integer, then two modes exist. Two modes exist. One is k and another one is k minus 1. Okay. If lambda equal to k plus f is a fractional value. Okay. Then mode is k. Okay. In binomial distribution, if np plus p equal to k, then there exist two modes. One of them is k, another one is k minus 2. Okay. If np plus p equal to k plus f, then the mode is k. Only one mode exists. Okay. Clear? So similarly here in Poisson distribution, if lambda equal to k, then two modes exist, k and k minus 1. Lambda equal to k plus f, then mode is k. Clear? Okay, so let us do some problems on Poisson distribution. In Poisson distribution, if probability of x equal 0 equal to probability of x equal to 1 equal to k, then find the value of k. Okay. So what is the formula for Poisson distribution? Probability of x equal to r equal to e power minus lambda power r by r factorial. Okay. So by using this formula, so this is e power minus lambda power 0 by 0 factorial equal to e power minus lambda power 1 by 1 factorial equal to k. So lambda power 0 is 1 and 0 factor also 1, so which is e power minus lambda equal to e power minus lambda into lambda equal to k. Yes? Fine. Now by comparing these two, what you will get? Lambda equal to 1. Yes or no? E power minus lambda will be cancelled. Lambda equal to 1. Okay. Now by comparing first and last, so e power minus 1 equal to k. So therefore k equal to 1 by e. Clear? Okay. So if m is the variance of a Poisson distribution, then the sum of the terms in odd places is. Okay. So variance. What is the variance of a Poisson distribution? Lambda. The variance of Poisson distribution is lambda. Yes, mean and variance both are lambda. Now the sum of the terms in odd places. So sum of the terms in odd places. So odd places means first term, third term, fifth term. First term is probability of x equal 0. Probability of x equal to 2 because it is started from 0. Okay? Plus probability of x equal to 4 plus so on. Clear? Now this is e power minus lambda power 0 by 0 factorial e power minus lambda square by 2 factorial plus e power minus lambda power 4 by 4 factorial plus so on. Yes? Now this is equal to, you can take common e power minus lambda, then lambda power 0 by 0 factorial, which is 1, which is lambda square by 2 factorial plus lambda power 4 by 4 factorial plus so on. Now this is equal to, what is the value of lambda? The value of lambda is m is given. So e power minus m into 1 plus m square by 2 factorial plus m power 4 by 4 factorial plus so on. Okay. Now this is equal to e power minus m. What is the value of this expression? Which is nothing but cos hx form. So cos hm. Cos hm. Is it clear? Okay, next problem. So a factory manufacturing laser blades. Okay. So in manufacturing there are some defective blades. Okay. So there is one blade out of 500. Okay. So man 500 blades తీసుకుంటే one blade is defective and the blades are in a pack of 10. Okay. ఆ blades అనేవి ఒక్కో ప్యాకెట్లో 10 అన్నమాట ఉన్నదన్నమాట. Clear? So then what is lambda? Lambda equal to 10 into 1 by 500. Okay. Clear? So blades and 1 in 500 blades is estimated to be defective. The blades are supplied in packets of 10. Okay. Clear? Kabatti 10 into 1 by 500. So which equal to, what is the value of this one? So 0.02. So this is the lambda value. So this indicates the defective blades యొక్క possibility అన్నమాట. ఓకేనా? Fine. Now we have to find in a consignment of 10,000 packets. Okay, any packets? So capital N equal to 10,000 packets. Okay, using Poisson distribution, approximately the number of packets which contain no defective blades, the number of packets which contain no defective blades. Okay, so what we have to find? Probability of no defective blades. Okay, probability of no defective blades. So that means probability of x equal to 0 because the number of blades defective 0, no defective blades అడిగారు కాబట్టి probability of x equal to 0 we have to calculate. Now this is equal to e power minus lambda power 0 by 0 factorial, which equal to e power minus 0.02, e power minus 0.02. Lambda power 0 is 1 and 0 factorial is 1. Clear? Now by expanding this, what you will get? 1 minus 0.02 plus, so 0.02 whole square by 2 factorial minus so on. Okay, now this is equal to 1 minus 0.02 plus, so what is the value of this one? 0.0004, yes or no, by 2 factorial is 2 minus so on. So which is equal to 1 minus 0.02 plus 0.0002 minus, yes. Okay. Now okay, so the terms after this okay, the terms after this will be neglected because they are very very small. Okay, because we want approximate value, so we will eliminate all those values. Now so this is equal to, so what is the value of this one? So this is 0.98 plus 0.0002. Okay, so this is equal to, so 0.9802 approximately. Clear? Now the probability of no defective blades is 0.9802, but how many they asked 10,000 packets, okay, in 10,000 packets, okay. So therefore in 10,000 packets, so 10,000 into 0.9802, yes, which is so 9,802. Clear? So these are the not defective blades in 10,000 packets. Okay, next, if probability of x equal to 1 equal to probability of x equal to in Poisson distribution, then find probability of x equal to 5. Okay, so from this, e power minus lambda into lambda power 1 by 1 factorial equal to e power minus lambda into lambda power 2 by 2 factorial. Clear? Now e power minus lambda will be cancelled. Okay, e power minus lambda will be cancelled. So then, so this is lambda equal to this is lambda square by 2. Clear? So lambda square minus 2 lambda equal to 0. So lambda into lambda minus 2 equal to 0. So lambda equal to 0, lambda equal to 2. So which is not possible. Okay? So lambda equal to 2. Now we have to find probability of x equal to 5, which equal to e power minus lambda, lambda power 5 by 5 factorial, which equal to e power minus 2, 2 power 5 by 5 factorial. Clear? So e power minus 2, 2 power 5 is 32. Yes, 2 power 5 is 32. So 5 factorial is 120. Yes, 120. So which is, so 4 8 4 30, yeah, 2 4 2 15, which is 4 into e power minus 2 by 15. 4 into e power minus 2 by 15. Clear? So this is Poisson distribution. Okay, so that's all. Very simple. You have to concentrate only on formula, which is probability of x equal to r equal to e power minus lambda into lambda power r by r factorial, where lambda is the Poisson variate or parameter of the Poisson distribution. Clear? And the mean of the Poisson distribution is lambda and variance also lambda. Okay? And Poisson distribution has mode in different ways. If it's depend on the lambda. If lambda equal to a integer, then there exist two modes. Okay? So one is k, another one is k minus 1. If lambda is not an integer, that is lambda equal to k plus some fraction, k plus f, then the mode is k. Okay? So generally the Poisson distribution will be used, okay, where the probability, okay, where the trials we can't decide exactly, okay, okay, in that case we have to use the Poisson distribution. Okay, for example, the number of snake bites in a city in a particular time, or a number of accidents in a factory in a particular time, because we can't decide. Okay, so in such a case we use this Poisson distribution. Okay, so this Poisson distribution is introduced by the S.D. Poisson. Okay, so on his name this distribution will be given as a Poisson distribution. Okay, that's all.